Hi guys, this is Totsum. Today I'm going to talk about hydrogen fuel cell overview and industry outlook. I hope this time will give you an opportunity to gain the wisdom of looking at the market from others' perspective. So let's get it started. The principle of fuel cell has been heard by you. It is a generator that uses energy generated when hydrogen and oxygen meet to make water. Unlike batteries, energy stored in fuel such as hydrogen, natural gas, and methanol. And fuel reacts with air in the fuel cell stack to obtain electricity. There is an anode to which hydrogen is supplied and divided into ions and electrons. Electrolyte membrane through which hydrogen ions pass, and a cathode through which air is supplied. And the electrolyte membrane are combined with electrode to be called MEA, membrane electrode assembly. And this is the core component of a fuel cell. Outside this, a carbon paper or carbon cloth called GDL supports the electrode. Here is GDL. And spreads fuel in horizontal directions. And the gasket and bipolar plate are located outside it to support MEA and supply fuel and air. We call bipolar plate as a separate of unit cell. It allows water to be discharged well outside fuel cell. In addition, these unit cells are stacked from tens to hundreds to form a fuel cell stack, which accounts for about half of the cost of the system. These fuel cells can be classified into five major types depending on the types of electrolyte. And I will talk about the characteristics of PFC, PMFC, MCFC, and SFC. Let's begin. The electrolyte for PFC use liquid H3PO4, and PMFC electrolyte is solid polymer membranes such as Nafion, and FC use KOH, and MCFC use lithium carbonate or potassium carbonate, and solid oxide fuel cell use YC. A charge carrier is hydrogen ions, protons, and OH minus and CO3 minus, and oxygen ions and or hydrogen ions. For PMFC AFC is a low temperature fuel cell, such as operating temperature is about less than 200 degrees Celsius. MCFC and SFC is high temperature SFC, so fuel cells such as over 600 degrees operating temperature, and only MCFC and SFC enables internally forming, and the system complex is MCFC is most highest. For PFC, phosphoric acid fuel cell, first generation fuel cell for power generation, and a representative company is Doosan Fuel Cell. It has a similar structure to PMFC, but use liquid electrolyte, as I mentioned, and use platinum catalyst because it is a low temperature fuel cell with an operating temperature of about 200 degrees Celsius. Therefore, about 10% of system cost is occupied by the platinum catalyst, and pure hydrogen is supplied as fuel, but is more stable with a little more impurities than PMFC. The main product is 440 kilowatt class PFC with a power generation efficiency of 43%. And it can be extendable to megawatt class. And its lifetime is 40,000 to 6,000 hours long. But it has expensive platinum catalyst and also have a CO and sulfur poisoning issue. And there needs a continuous supply of liquid electrolyte during the operation. There is an MCFC, second generation. Representative company is Fuelcell Energy of United States and POSCO of Korea that introduced Fuelcell Energy technology. Until 2 years ago, it was the most actively installed fuel cell for power generation in Korea. It has the following characteristics like this. It's suitable for stationary power, and you can use various fuels such as coal, natural gas, methanol, and biogas. And using internal reforming, its efficiency is rather high, and it has no CO issue. It can use CO as a fuel, but there is a stack lifetime issue. In use highly corrosive molten carbonate, then there is a need to develop corrosion resistance materials. As an SFC, solid oxide fuel cell, it corresponds to a third generation fuel cell. The operating temperature is very high, from 600 to 10,000 degrees Celsius. And electric efficiency is over 60%. So it's being developed for power generation as well as for ships and automobiles. And Bloom Energy is the representative company. And Doosan Fuelcell is also developing technology in cooperation with Ceres Power in this field. Due to its high power generation efficiency and simple structure, it is advantageous for cost reduction and system miniaturization. And development and commercializations are underway as a next generation household fuel cell. The main technical features is as follows. In use electrolyte as YSD, and in use nickel YSD thermal as anode, and cathode material is perovskite structural ceramics such as LSM or LSCF. Interconnecting materials are doped lanthanum chromite. And nowadays there is need to develop mid-temperature SFC, such as operating temperature is about 400 to 700 degrees. It can enable the cost reduction by replacing the ceramic materials. The representative company for each fuel cell are as follows. For power generations, PFC is Doosan, MCFC, POSCO, PMFC, Toyota and Hyundai, SFC is Bloom Energy. For automobile, there are two companies have a lot in common, and the performance is similar. And with the support of Korean government, which invests heavily in fuel cell for transportations, Hyundai is slightly ahead of its sales with 12,000 units. Now, let's take a look at the driving principles of hydrogen vehicles, FCEV. Hydrogen fuel is in hydrogen tank, stored in hydrogen tank at high pressure over 700 bars. And the stored capacity of this hydrogen storage tank determines the mileage. About 5 to 6 kilograms of hydrogen can be stored, and Driving distance is about 600 to 700 kilometers is currently possible. High pressure hydrogen is supplied to fuel cell stack by lowering the pressure through regulator, and oxygen is supplied to air through a compressor or blower. Fuel cell system consists of mainly 4 parts: fuel cell stack, and FPS, fuel processing system, and APS, air processing system, and thermal management system. Here is a thermal management system. Motor and inverter. Lithium polymer batteries is also needed as EV. Additional hydrogen tank is also needed, which is expensive type 4 tank. Looking at the cost structure, fuel cell stacks accounts for about 40% of the cost of hydrogen vehicles, and in the case of stacks, catalyst 16% and GDR 18%, membrane 32%, and separate 14%, gasket 10%, based on the production of 10,000 vehicles. In the case of Nexo, we make up the stack cost about 34%, FPS 1%, APS 12%, TMS 2%, and hydrogen storage 17%, and electric equipment 12%, and chassis 12%, and estimates the total cost of 51 million won for 10,000 vehicles production annually. If you look at the result of FCEV cost estimation simulation predicted by DOE in 2012, the cost will decrease in proportional to the production volume. Based on the current 100 kilowatt FCEV systems mass production volume of 10,000 units, the cost is $5,900 per system. In the case of mass production of 500,000 units, it can be seen that additional cost down of about 20% is possible, up to $4,700. This is the fuel cell system cost. The MCFC cost is expected to decrease about 33% from $30,000 per kilowatt when producing 100 megawatt volume per year, to $2,000 US when producing over 500 megawatt volume. In the case of PFC, a cost reduction of $11,000 US per kilowatt seems possible with a 40 megawatt production volume, but its platinum price accounts for about 10 to 20% of total cost. Regarding the market outlook for hydrogen economy, looking at the result of past 10 years, Japan's annual farm has increased rapidly to about 330,000 units, and it's known that the impact of Tokyo earthquake is major. The Korean market is the largest, accounting for about 43% of global fuel cell market, and is expected to expand the market by to 15 gigawatt by 2040. In the case of Korea, aggressive policies are being pursued with the goal of 80,000 fuel cell vehicles and 1.5 gigawatt fuel cell for power generation next year. But the full-fledged market expected in 2040s when the price of hydrogen fuel cell reaches $2.5 US. It gives economic grid parity. So fuel cells with the high energy storage densities are attracting attention in the areas such as aviations and UAM and ships, as well as fuel cell for automobiles and power generation. Fuel cells have an advantage over lithium battery because they can have a system weight density of up to 10,000 watt-hour per kilogram in the aviation field, and this field has a potential to grow faster than automobiles. In addition, since the marine fuel cell has less volume restrictions, the existing fuel cell technology for power generation can be applied. It is possible to design low noise, high power, and eco-friendly ships. Therefore, initial investment in this field can be viewed as promising. Finally, this is a SWOT analysis of hydrogen economy. Hydrogen energy is next generation energy that can achieve democratization of energy with the advantage of being abundant. But it is currently limited in that there is no economical technologies to produce green hydrogen, and it's difficult to produce innovative startup due to high capital barriers. However, there is opportunity factor that is supported by governments of each country as eco-friendly power generation technology and is compatible with alternative resources such as ammonia. As a threat factor, there are risks such as delays in industrial growth due to economic blockade or changes in subsidy policies. So it's important to accurately grasp each company's technology, capability, and business model and their visions. So thank you for watching my videos, and if you have any questions or comments, please leave it on my YouTube channel. So have a nice day. Bye.